Right, okay, for this one then we are looking at B2b, and we are looking at energy flow and how it flows through food chains, and in particular food pyramids, and we're looking at pyramids of number and pyramids of biomass. Now the thing you have to remember is that the energy originally always comes from the sun. Now the problem is that animals can't take in this energy from the sun and convert it into forms that are needed for the life processes. And I'm sure you remember that for every living organism they have 7 life processes that they use the energy for. That's movement, respiration, sensitivity, growth, reproduction, excretion and nutrition. Okay, and some people will know that as Mrs. Green. So the problem is we have to get this energy into the food chain and into the pyramid of numbers or biomass. So plants are known as our producers, because what they do is they take the light energy, the heat energy from the sun, and they convert it into an energy that can be stored in the form of glucose, so that when a consumer consumes the producer, the plant, then they can take in that energy. Now you have, initially it's just like at school, you've got primary school, secondary school and then college, but in this instance primary consumers are the first consumers to take in the producers, the secondary consumers will eat the primary consumers, and the tertiary consumers will eat the secondary consumers. Sometimes can be known as the top carnivores. At this point I just want to remind you that carnivores eat meat, omnivores eat meat and plants, and herbivores just eat plants. Okay, so if we look at that and how that transfers across, if you've got, for instance, a lettuce, which is the plant, and then you've got a rabbit that eats the lettuce, there's your primary consumer. Then you've got the fox that eats the rabbit, that's your secondary consumer. Each of those is called a trophic level. And also please remember that the arrows that can pass in a food chain are showing the energy transferred between each trophic level. So the food webs exist because consumers belong to one trophic level. Pyramids are actually used in biology to show you the feeding relationships, and this is an example of, for instance, of a pyramid of numbers, and you'll see they look completely different, and that's because we're talking about the numbers of organisms in this particular pyramid. So for the first one, for instance, you'll see that this is an oak tree. Well, there's only going to be one oak tree, and then that has lots of insects living off it, and then the bird, the woodpecker, will eat the insect. So you'll see it looks a bit weird because it doesn't look like a pyramid, and that's because it's a pyramid of numbers and each bar represents the numbers. Whereas the one on the right, where you've got clover at the bottom, you'll have a lot of clover supporting a few snails. Those snails will support the thrush, and then the thrush will support the sparrowhawk at the top. And so it does look like a pyramid. Now you need to remember this, that pyramids of numbers can look odd, but pyramids of biomass always look like this. They always have a larger bar at the bottom, a larger trophic level, then a smaller one, and then a smaller one. And scientists have carried out lots of experiments to prove this, that it always looks like a pyramid. Now biomass, think about the word bio. Bio is to do with living, and mass is to do with the amount of stuff that's there. So it's the amount of living stuff in a particular organism. Now scientists, they always like to say that they prefer to measure dry mass, so they'd have to take all of the water out. Okay, and it can only obviously be an estimated mass, because if you think about the oak trees have got roots that go deep underground, and obviously we don't want to cause harm to other living organisms as well. So if we're looking at pyramids of numbers, but looking at energy and how the energy transfers along the pyramid, if you think about, let's just say for instance the sun is 100%. To pass into the first trophic level, that plant might produce 70% energy, and then the primary consumer might then have 40% energy. Now you might say to yourself, okay, well, where's all that energy gone? And again, you need to think about that the living organism itself needs to take energy to survive, and also it needs to excrete, and it needs to get rid of its own feces. But also waste gases can be excretion as well. So if you're asked a question, how could you reduce the loss of energy along the food chain, then you could say, well, actually, if we took out one of the trophic levels, so the top consumer actually didn't eat, so for instance the secondary consumer didn't eat the primary consumer but went straight to eating the producer, it would get more energy. And if we had to calculate the efficiency of a living organism, we would say the energy used divided by the energy supplied times 100, because efficiency is always measured as a percentage. Now please use your common sense here. If you do a calculation and you get something that's like 120 or 0.6, then that's not going to be the correct answer. It's the energy used divided by the energy supplied. Thank you.